So this lesson is going to be a recap lesson and should be a bunch of things that you already know how to do and then a little bit of new stuff at the end. So first of all, let's write down all of the identities that we need for this chapter. The Pythagorean identities: sine squared of, I'll pick variable x, plus cosine squared of x equals 1. Let's divide each of them by sine squared. That makes a 1. Divide by sine squared, cotangent squared. Divide by sine squared, cosecant squared. Let's divide by cosine squared. That makes tangent squared. Let's divide by cosine squared. 1. Divide by cosine squared makes secant squared. The sum and difference formulas. These are our songs. So go ahead and take it away. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. And remember, it goes A and then B. If it's plus and then minus, it's plus or minus. Sine, cosine, cosine, sine, and the letters are A and then B and then A and then B. But it goes cosine, cosine, clap, clap. So plus or minus switches to minus or plus. A, B, sine A, sine B. And tangent has a huge fraction, and it goes tangent of the first angle plus or minus tangent of the second angle. 1, and then there's a switcheroo down there. So if it's plus, it switches to minus, and minus switches to plus, so change, and then it's tangent of A times tangent of B. Okay, very good. The double angles. If you forget these, you could always do sine of x plus x and make them, or hopefully by now you remember 2 sine x times cosine of x. Cosine squared had a variety of formulas. Cosine of 2x rather is cosine squared of x minus sine squared of x. And there are a couple more versions. If I replace cosine squared with 1 minus sine squared, there's another sine squared, so that's 2 sine squared of x. Or we could have 2 cosines squared x minus 1. The tangent formula is 2 tangent of x divided by 1 minus tangent squared of x. Those are the double angle formulas. And the only other ones that we have are the halves. And the halves are the uglies. Remember how there's plus, minus, big, radical, plus, minus, big, radical for all three? If it's sine, it's going to be 1 minus cosine. And since this is half of x, this is a full x over 2. Cosine gets 1 plus cosine. This is the half, so you put a full x over 2. And tangent is sine over cosine, so that means it's 1 minus cosine of full x divided by 1 plus cosine of full x. That is not the easiest one to work with, though. If I grab that numerator and say 1 minus cosine of x, then it would be divided by sine of x. If I grab that denominator, 1 plus cosine of x, then it would have a numerator of sine of x. And of the three, the easiest to calculate with would be the one with the nice, easy denominator. Just less rationalizing. Okay, let's do a variety of problems here. Using sum and difference, you have to add or subtract two things to make this angle. So this is going to be tangent of some sort of 12s and some sort of 12ths. Let's put some pi's. To make a 1, we'll probably go ahead and subtract. We could do 4 minus 3 or 3 minus 2. Let's just do 4 minus 3. Variety of answers. We'll get the same answer. Your work will be different. So that means we have to calculate tangent of pi over 3 minus pi over 4. Okay, let's use the sum and difference. That's that big fraction-y one up there. Equals tangent of pi over 3 minus tangent of pi over 4. In the bottom, we'll do switcheroo to 1 plus tangent of pi over 3 times tangent of pi over 4. All right, so I've got a tangent and a tangent, 1 minus, the same two answers. So tangent for pi over 3 is radical 3, there and here. Tangent of pi over 4 is 1 and 1. So now we have radical 3 minus 1 over 1 minus, no, that's supposed to be plus. What am I doing? Plus radical 3. Okay, halfway done. Time to rationalize. We're going to multiply top and bottom by the conjugate of the denominator. So 1 minus radical 3. All right, doing that is going to make a difference of squares in the bottom. And that's going to be 1 minus 3. The numerator is going to be radical 3. All right, let's just write this out. Radical 3. The outers is minus 3 minus 1 plus another radical 3. So that's 2 radical 3 minus 4, and the denominator is negative 2. I'm going to give each of them a negative 2. So the final answer is, I'm going to put the positive one first. 2, cancel, cancel, minus radical 3. So you have to know how to add or subtract fractions, make angles from the unit circle, know the formula, know the values from the unit circle, know how to rationalize, don't make any mistakes. Okay, that's why this is a tough chapter. Number 2 is a graphing one. Let's see, this looks like a song. Sine, sine, cosine, cosine. That's not the usual song. It's usually cosine, cosine, sine, sine. But it's negative here. I think I'm going to have to factor out a negative. Let's factor out a negative. That would make these cosines positive, so let's put them first. Cosine, cosine, minus sine, sine. Okay, and let's check the angles. Do I have an A and a B and an A and a B? Good. Okay, so we've got negative cosine, this is the cosine song, of 2x plus pi. All right, is that equation ready to be graphed? No, because we got to factor out that b number. Okay, so let's make sure we do negative cosine 2 times the quantity x plus pi over 2. All right, a couple of questions here for you. What is the period going to be? 2 pi over b, the period's pi. What's a section? Let's divide by 4, pi over 4. And let's not forget to shift to the left. And let's not forget to reflect or start at a low. Okay, no up-down shifting. All right, so we're going to label our x-axis by pi over 4s. 2 over 4, 3 over 4, 4 over 4. Let's label the negative ones. Negative 3 over 4, negative pi. The amplitude is 1. Okay, so we're good with that. 1 and negative 1. And let's start to the left, pi over 2. So is this cosine graph going to start high, middle, or low? Cosine usually starts high, but this is a negative one, so we'll start low. And then we'll go up, up, down, down, up, up. Let's go up here, up, up. Perfect. All right, keeping our graphing fresh. All right, what else have we studied so far this chapter? Let's verify an identity. So we have to show how cosine of A alpha plus beta plus cosine alpha minus beta makes that. So I'm going to pick left-hand side, and it seems like we might have to do a sum and a difference rule. Okay, so cosine of alpha plus beta is cosine cosine switcheroo, minus sine alpha sine beta. Okay, plus, let's do some more. Now I got to do a difference. Cosine, 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 switcheroo, plus sine, sine, sine alpha, sine beta. These are terms. There's 1, 2, 3, 4 terms. And this term right here is a negative sine, sine, and here's a positive sine, sine, and the angles match. So those terms can cancel. These terms are like terms, which means I have 2 cosine alpha times the cosine of beta, which is the right-hand side, so we are done. Half-angle identities, remember these are the uglies, okay, and this is cosine. So this 112.5 is the half, and the half is in quadrant 2, and the full angle is 225, which is here. Here's the full angle, 225. Okay, that's the full angle, full alpha. So since the half is right here, it's negative comma positive. Should I pick the plus sign or the minus sign for cosine? Let's pick the minus sign. Remember how ugly these are? Big radical. What goes in the bottom? A 2. The cosine formula is 1 plus cosine of what? You put the full angle. You write 225. Okay, now we're all set up for doing some evaluating. So we have a negative square root of 1 plus, what is the cosine of 225? Negative radical 2 over 2. How should I write the 1? As 2 over 2? How should I write the 2 over 1? As 4 over 2? All those denominators cancel out, and so we have the negative square root. 2 minus radical 2 over 4. Can that 4 come out? Absolutely. Negative square root of 2 minus radical 2, and outside the radical, a plane 2. Okay, half angle identities for a tangent problem. So let's see if this is the half angle. Where is 7 out of 12? 12 out of 12 would be here. 6 out of 12. So 7 out of 12 is right here. Here's the half. So where would the full angle be? 7 out of 12 times by 2 is 7 pi over 6. 7 pi out of 6 is right here. 7 pi out of 6. Okay, tangent has a variety of formulas, but the one that I think is the easiest is the one that goes 1 minus cosine of the full angle, 7 pi over 6, divided by the sine of the full angle, 7 pi over 6. Okay, unit circle time. What is the cosine for 7 pi over 6? Negative radical 3 over 2. And what's the sine for 7 pi over 6? Negative 1/2. Negatives cancel. Let's write this 1 as 2 over 2. So now we have 2 plus radical 3. All the denominators cancel over negative 1. Let's give them each the negative 1. And so the final answer is negative 2 minus radical 3. Okay. Other things that we did was draw pictures in quadrants. So let's draw a couple of diagrams here. Alpha is in quadrant 3. So we're going to draw alpha right here. And tangent is opposite over adjacent. Pythagorean theorem, 3 squared plus 2 squared is going to be the square root of 13. Oh, but hang on, this is quadrant 3. So both of these, let's use a bright red here, should be negative. Okay, and beta is in quadrant 2. Beta 2, here's beta, the sign is opposite over hypotenuse. No negatives there, but here I'm going to need a negative. And if I do Pythagorean theorem, 9 minus 4 is going to be radical 5. All right, let's find the following. Ooh, a sum and difference. That's a song. Okay, how do you do a song? Sine, cosine, cosine, sine. No switcheroo with the sign. Alpha, beta, alpha, beta. Okay, let's put some fractions in here now. What's the sign of alpha? Let's look at the alpha picture and say negative 2. Let's rationalize. Negative 2 radical 13 over 13. Cosine of beta would be negative radical 5 over 3. Cosine alpha is negative 3 radical 13 over 13. And sine of beta is 2 over 3. Well, the good news is at least we have common denominators. The bad news is these are getting pretty ugly. Okay, so we have a negative times a negative makes a positive. We have 2, and 13 times 5 would be 5, carry the 1, 65. And the common denominator here is going to be 39. This is going to be minus 3 times 2, 6 radical 13. Common denominator 39. Those are not like radicals. So when we add them together, we're going to have 2 radical 65 minus 6 times the square root of 13 with a common denominator of 39. Okay, that's great. How about a double angle formula? The double angle, for cosine I like especially. It goes cosine squared of beta minus sine squared of beta. Okay, so we're just going to use the beta picture here. We have to find the cosine fraction and square it, and the sine fraction and square it. Cosine would be adjacent over hypotenuse. So that's going to be negative radical 5 over 3. And the sine is going to be 2 over 3. And so this makes 25. And this makes 4. The common denominator is 9. So our answer is 21 over 9. And a half angle. The half angle is determined by the quadrant it's in. So full alpha is in quadrant 3. Where's the half alpha going to be? The answer is quadrant 2. And the cosine value there is negative. And the formula is 1 plus cosine of the full angle. And using the full alpha picture, what is the cosine? Negative 3 radical 13 over 13. So how should I write the 1? 13 over 13. And let's write this as 26 over 13. And so our final answer is the negative square root of 13 minus 3 radical 13 all over 26.